I am Nicole Borrelli, a developer programs engineer at Google from Mountain View, and I'm going to chat with you a little bit about the Android Q privacy changes and what you have to do to adapt your app for them. So first, 10 years ago, we put up this slide at Google I/O talking about how fast Android is growing. And it did pretty well. And over time, mobile OSs have matured, and user expectations and behaviors have also matured. Nowadays, people are much more conscious of their privacy and especially what sort of data they're sharing with apps. We knew early on that privacy was going to be a key theme going into Android Q. And we wanted to make sure that we could build upon all of the different privacy features that were present in the OS. And so we have in Q, we focused on 4 interlocking features. So we have user control. We wanted users to have more control over their data and when and how they want to share it. To support this, we updated the system UI to give them more levers and controls on how to do that. To help developers, we updated some of the framework APIs to work better when granted, or when granted different permissions, and we're able to be more focused. And then with play policy, to make sure that while we're making the changes on Q for limiting access to certain pieces of data, we can make policy changes that, in effect, allow those restrictions to work on older OSs, even though we might not be able to update them the same way. The biggest takeaway from this talk is this. When you're creating an app, you should only want to request permissions for the data that you actually need and when you need it. You should provide graceful delegation for your users when they don't want to grant that permission. And especially in Marshmallow and Plus and we expect on Q, always check what permission you have granted before you access it to avoid security exceptions. So let's go into some of our keys. So before Q, the only way to request location permission was to request it all the time. So your users had to choose whether to grant location access to an app all the time or never. And this led to some unfortunate lack of transparency with regard to certain apps, where users would have expected that the app only used their location while they're in the app, but for other reasons it was accessing it outside when they were using it. So in Android Q, we added the ability to grant the permission only when the app was being used. And so if you're targeting a pre-Q, you end up with this dialog where the user can grant the permission for the app to access their location either all the time, only when the app is in use, or they can deny the application. So when the user grants access to the app to access their location when the app is in use, that's in two situations. That's in two situations. So the first is when there's a foreground activity, which includes multi-window or split screen, or when your app is in picture-in-picture mode. It also includes foreground services. So if you leave Google Maps, for example, the turn-by-turn directions pop up as a foreground service. So for example, if we have monitoring commuter and it wants to access your location only while you're using the app, in its targeting queue, it can request just the course or find location, and this will make this dialog box pop up. And this is really nice for the user because now the user knows immediately that no matter what they do, the app can, monitoring commute is only going to be able to access their location when they're in the app and they have it open. The other benefit of asking for only while in use, at first at least, is that let's say that I'm using the app and I stumble upon some more advanced use cases, and I would like the app to track where I am to give me alerts or something like that. Then the app can prompt at that time to get access in the background. And you can see that at that point, I can grant it access to my location all the time. I can leave it as it is, or I can leave it as it is and reject any further requests for background location. But now, if you got to this point, at least the app can use your location while the app will be able to access the user's location while they're in the app. So the other interesting thing to remember here is that, so we were looking at maps before, and we started doing a trip. If at this point I exit out and go to home, then it will start a foreground service like this. If you are targeting queue, you need to add a new flag in or whether you're targeting queue or not, you have to add metadata to your foreground service to say that it wants to have access to the location, and you give it a type. Just make sure that you do that when you start deploying to queue. Otherwise, foreground services won't be able to get access to the location. Another big change is around external storage. So one of the reasons that we made this change is that some users felt as though apps were not using their SD card as they would have expected. And so we wanted to make some changes to help users keep their SD cards more uniform, or able to be used the way that they wanted. So before we had, this is our view of storage. So we had internal storage, which is private to your app and will always be. And then we have common storage, where you have files that are accessed with get external files there and the similar APIs. And for those, from KitKat on, you didn't need any permission to access those locations. If you wanted to access photos, audios, or other documents, you needed the read external storage permission. On Android Q, external storage is still private to the app. Package-specific files don't require any permission, so that stays the same. In order to access photos, videos, or audio, however, you need to request the read external storage permission. The one exception for this is that if let's say that you had a camera app and you were contributing files to the media store, you'll be on Android Q, you can read those files back out without any permission. On previous versions of Android, you would have needed the read external storage permission. And then for downloads and other file locations, you need to use the storage access framework to get access to that. This is the way that it was designed to work in Q. If this doesn't work for your app, it's possible to request to fall back to the old behavior with a manifest flag. The manifest flag is the result of that is set by the installer at the time that it's installed. So if you sideload, it would be granted probably. If you're installing from installing from the Play Store, then at some point that could change, but it's just something to be aware of. If your app doesn't work with the storage access framework and and you have details about why and how you think that we can improve this, please leave us feedback because we are continuing to iterate on this. Another unfortunate side effect of having some API, or one of the unfortunate side effects of having such open APIs, is that sometimes the APIs are abused. For example, there's a flashlight app that was constantly popping up ads, and it was causing some potentially dangerous situations. So looking at this, so this is the way that it was working before. And as soon as you dismiss an ad, another ad would come up and take its place. And it was not the greatest experience. On Android Q, however, this was fixed. Now, obviously, there are some times where you want to get the user's attention for legitimate reasons, not continuously popping up ads. So, for example, the best approach now is if the app is in use, to just show it. Otherwise, you can show a heads-up notification and the heads-up with a full screen intent. So then if the user is using an app on their phone, they get the notification and they can respond to it. If they're not using their device, then they get the full screen notification, which you can see, which works the same way that like the dialer does it now. There are a number of different exceptions for when you can launch activities from like a broadcast receiver or a service, even in Q with the restrictions. The most obvious is if you have a window that's visible in the foreground. The next one, which is a little bit trickier to follow, is that if you have an activity in the backstack, so if you launched an activity over top of you, you can still launch an activity from the background, since you're still in the backstack. If the system is bound to a service of yours, you can launch an activity. And these are a couple of examples. And then if another app is sending a pending intent, or the system is. This doesn't work for the alarm manager, for example, so you can't just set an alarm and then decide whenever it goes off whether you need to launch an activity. So just also keep that in mind. Some users have some strong feelings about accessing read phone state. And we sort of can understand about that, and generally hardware-based IDs. In Android Q, we're adding restrictions to generally the hardware-based non-resettable IDs. So, for example, only the system can read IMEI and build serial numbers now. If your target SDK is less than Q, and you have read external phone state, and you try to get the IMEI or the MEI, it will return null. If you don't have the permission, you'll get a security exception like you would in the past. If you target Q or higher, then you'll get a security exception regardless. So make sure to test your apps thoroughly once you do start targeting Q. In general, the best practices for IDs are these. If you're trying to track cross-app installations using Android ID. If you just want analytics data, creating your own UUID is probably the way to go. And then when if you're trying to track the user for targeted ads, then the advertiser ID is the way to go. So, big thing here is check to see if you're using get device ID or get IMEI or the build serial number, and check to see why you're accessing that and if another ID might be a better fit. And then after you've done that, you can remove the read phone state. So again, takeaway is to try to only request permissions that your app absolutely needs. Provide fallback behavior for when the user doesn't grant your app permissions, and always make sure to check your permissions before you're accessing restricted data, so that you don't end up with crashes and that sort of thing. And that's